1 second, please.
Take your time.
Okay. Can you see the screen?
Yeah.
So should I explain what I did? Or?
Yeah.
So I created a class custom integer, as we were supposed to be, and used the protocol equatable and custom string convertible. Equatable makes you implement this function here, which allows you to use this operator to, well, equate two instances of this class. And I just checked if they have the same value. Then the custom string convertible well, makes you implement this variable description, which is a string, which allows you to have a beautiful presentation of the values of your class, so that you can customize this. Then, of course, I have the integer value as a variable. Then for the operator overloading, well, you can just use a function with the operator as a name. And I used then again the class as left-hand side and right-hand side, and returned a new custom integer, so a new instance of the class with both of the values added or subtracted.
Yeah.
In the other case. I thought about just returning the value itself, but I think that's nicer. And I just put the encryption, although it doesn't really fit here, but I put it in the same class, and I thought it's basically just a Caesar cipher, so you just have to rotate the string by 1. Yeah,
exactly. It's a shift cipher. Yeah.
And therefore, I just used the string, got the Unicode scalars, and added 1 to the value basically, and returned that as a string again.
Yeah, great. So yeah, the purpose of the second exercise was to work with the dictionary, but yeah, the solution is totally valid. Great job.
I mean, it didn't say to use a dictionary anywhere, so.
Yeah, fair. Yeah, great job.
Thank you.
So I will then start sharing my screen. Do you see it?
Yes.
Great. So sorry?
Ask you because I saw he used like the dictionary and did it in like one short line, the whole code. And is it like, do we had to use this dictionary, or could we also like solve it with another way, like a double for or something?
To be honest, all the solutions are valid. when the result is the same. It's just basic exercises to get you used to using Swift, but
okay.
There are no strict requirements to do some specific operations.
All right. Thanks.
Yeah. So everything is great. If it works, it's great.
Okay.
So, as far as I know, you stopped with Ralph right before the patterns, right? If I'm not wrong. So you learned about application states, app delegates, app termination, and now we're going to continue with the patterns. A pattern is an approach in programming to solve a problem. And usually this problem is not really language specific or platform specific. It can occur everywhere, and the solution would be pretty much the same regardless of the programming language. And a pattern is a named and structured solution to that. So it is important to use the right terminology so that you can kind of speak the same language with other engineers when discussing the problem and the solution, so that you wouldn't need then to explain step by step your solution, what exactly you're going to do. But you would just say that you're going to use this pattern and everyone immediately understands what exactly is that. So, for example, if you say, yeah, here I'm going to use delegation pattern, then everyone understands what's that, and you don't need to say, I'm going to create a protocol with this and this method, and I'm going to invoke it there and there. So it kind of makes the communication easier. There are quite a few patterns out there, even groups of patterns. There are books on that if you're curious to look into it. Some are more common on iOS and some are not so. And here we are going to discuss just a couple of them, which are commonly used on iOS in iOS SDK. But yeah, as I said, I would recommend you to look them up yourself, just to not to try to reinvent the wheel when you're trying to find a solution, because engineers came up with these patterns many years ago, and it's already proven to be effective in solving specific problems. Yeah. You also need to be aware of the solid principles. Again, there are a lot of them out there, but these are the most popular ones, and they help you to keep your code reusable, testable, and maintainable, what is the most important. And there is a principle on each letter of the word. So S stands for single responsibility principle. That means that every class should have just one responsibility. The same class shouldn't send requests to the backend and save the data to the database directly. It's two separate responsibilities, so try to keep it this way in your code as well. The next one is open-closed principle, which means it should be easy to expand your code, your class, to add new features, but it should be closed for modification from the outside, because modification can potentially break the functionality which you wrote. Then L stands for Liskov substitution principle. That means that objects in your program should be replaceable with the objects of their subtypes without breaking the correctness of your program. So, for example, if you have a class which works with the objects of a base class vehicle, it still should be able to work correctly with the objects of classes car, yacht, plane, or a bike. Then goes I. It's interface segregation principle, which stands for many client-specific interfaces are better than one generic purpose one. So that means that, for example, having methods available that you don't need, it adds clutter and noise and makes it harder to maintain the code. For example, it makes sense to have some functionality in the base class vehicle when it's relevant for all any type of vehicle. But if it is relevant only occasionally, for example, flying functionality makes sense for jets or airplanes. So you should have them there instead of exposing this functionality to every subclass of this base class. And the last one would be dependency inversion principle, which stands for depend on the abstractions, not concretions. That means if your class depends on some functionality, implement this dependency as a protocol so that depending on the circumstances, you could pass different implementations of this protocol. So, for example, you need some network module for your controller to be able to fetch user data from the server. So the correct approach would be to create a protocol with, for example, get user data method and make it a dependency for your controller. And then make the network module conform to this protocol. This way, you can also pass a mock class, which conforms to this protocol as well, for testing purposes, because it's better to avoid making actual requests in some type of tests to avoid flakiness. Yeah, and you can pass a proper network module in the production code. And just to show an example, let's go to the playground. So yeah, that's exactly the example I was talking about. Imagine you have a user with some data, in this case, just ID and name. This model represents what you would receive from the server if you perform a request. And then you have user profile controller, which is supposed to fetch the data and make the view display this data. And controller can get this data from the repository, so some storage of the data, remote or local, doesn't matter. And we don't really want controller to have a dependency as a concrete type. So it's better not to have it as just user repository, because then if you decide, not if you decide, but when you're going to write tests for the controller, you will need to provide the actual instance of the repository which performs the request to the server, which is not really great, because it won't be then a unit test if you perform requests. But if you have this dependency as a protocol, so just as an abstraction, then depending on what you're going to do, you can pass different instances of different implementations of this protocol. So here, for example, we are making some request, and in the mock user repository, we just return a test user, which would be perfectly fine for testing. And when we write a test for user profile controller, we would just say, okay, user profile controller, repository, new mock user repository. Yeah. So that would be dependency inversion, because you depend on the abstraction, and the way you provide the dependency to the controller, that would be dependency injection principle. But that's also later a bit. Does it make sense to you? Okay, but if you have questions, just yeah, interrupt me and ask. And yeah, as I said, some patterns, some more common on iOS platform, especially on the SDK, so the code from Apple, and we are going to find out more about them right now. So the first one is model view controller, extremely popular pattern. So a lot of people refer to it as a design pattern. It can be also called as architectural pattern, but yeah, pattern either way. Basically, it makes it divides your app into 3 sections, and it clearly defines the responsibilities for them and the relationships between them. The central component of the pattern is model. This is applications data, so that would be data persistence, network modules, data sources, anything related to the data your app works with. So repository would belong to this section. Then goes controller. It's kind of a mediator between something a user sees and interacts with and your app logic and data. And then the last component is view. This is the way your app data is displayed to the user. The only thing which view is supposed to do is to tell the controller that user interacted with the UI. That's it. And after you let controller know that some action happened, controller decides how to act on it. It also knows. It also lets the model know that some data should be updated. For example, some requests should be performed, or something should be saved to the database. This way, the data gets changed. So the state gets changed somehow, and the controller is notified about that. And then controller also triggers the view to update the state. Yeah, in a bigger app, you would have groups of models view controllers, and they can also there could be multiple controllers working with each other, or multiple repositories, so depending on the functionality and on the size of your app, but always keep in mind the communication rules. And just to reiterate, model is the data representation, networking, database, parsing, helper, anything related to the data. And it should be split into separate files and responsibilities, as we discussed according to solid principles. So, for example, you would have a separate user data repository to fetch the data which is specifically related to the user profile. Then view, it shouldn't interact with the model or do network requests, anything like that. And controller, yeah, kind of a mediator between them. it triggers the model change and it triggers the views update.
I have a question.
Yeah.
So do you have multiple controllers for multiple views, or do you use one controller for all the views and all the?
So it really depends, but I would say that you should have a controller for a feature. So as an example, you have a user profile and you would have some user profile controller. Also, it can be a bit confusing because there are view controllers on iOS, so the ones which are holding the view and directly managing it. But if you keep all the logic of updating the model in the view controller, it makes your code not really testable. So view controller would be just the view view part of the MVC, and then you would create a separate controller which already triggers some model updates, and then you would have some repository, or I don't know, there could be multiple ways to structure your model section of MVC. But again, depending on your screen, for example, if there are many features there, it's totally normal to have multiple controllers which handle that, because different features can be reused in different places of your app. So it makes sense to have separate controllers to these features. And then depending on what functionality you have on this screen, on this view, you would use one or more controllers to handle this logic.
Okay, thank you.
And yeah, MVC is just one of the patterns which you can use on iOS. There is also MVVM, MVP, or Viper, but actually it's kind of up to you and up to your team to decide what you're going to use. But MVC is just kind of default option for that. And we're going to use it in this course. And another pattern which is used like literally everywhere on iOS and in iOS SDK is delegation pattern, and it is really important to understand that. So basically, a delegation pattern helps you to follow the principle of a single responsibility for your classes, and it kind of helps to keep your class focused on just one responsibility. This way you delegate everything what is not directly related to that. It delegates it to the external delegate. Sorry. Yeah, so for example, UI table view is a class in iOS in UIKit, which lets you display like a set of data, so cells. Like imagine a to-do list. You would probably use UI table view for that to display the tasks in your to-do list. And the way UI table view works on iOS is that the only thing which it does, it's actually just displaying these cells, and everything else, like construction of the cells or reacting on the user input, anything like that, it delegates it to outside. So you need to handle that when you use UI table view. And the only responsibility of the UI table view is to show these cells for you and handle some animations and stuff like that. Yeah, it just in general keeps your code more testable and lets you avoid unnecessary subclassing and stuff like that. Yeah, the delegating class has a reference to the delegate wire protocol and allows easy change of functionality and supports modularity. Here is an example. On the first screenshot, it's a user input view. So just imagine some text field where a user can type in something, phone number or whatever. And what you're doing, you add like a listener to your text input field, so that when something happens, this text did change function will be invoked. And then this user input view delegates to this user input delegate all the actions which should be performed after that. So user input view shouldn't decide what to do with this input, but rather the user of this class should decide what to do with that. And then when we are already in the view controller, so something what holds the whole screen. Yeah, I'm really sorry about the noise. So we have the user input view in the view controller, and then we set the delegate. You see here's this property delegate, and in the view controller we set it to self, because the view controller also conforms to this user input delegate protocol. And then we need to implement this function because of the to conform to the protocol, and we can react somehow when some input happened. Yeah, does it make sense to everyone?
I guess.
Mm-hmm. Yeah, later on we're still going to use it multiple times. So. And yeah, views. First, the most important view would be UI window. So the whole screen which you see on your device, this is UI window. So this is like a topmost container for all the views which you have in your app. And normally you have just one UI window per app. And yeah, as I mentioned, it is a container which keeps inside the whole views hierarchy. You can construct views in the code, so either using UIKit, as in this course we are focused on the UIKit, or since a couple of years you can use also Swift UI, which we are at least for now not going to cover in this course, but if we have time later, we could actually talk about that. And you can also construct the views graphically, so via the interface builder. And we are going to discuss both approaches and advantages and disadvantages of them. Views can contain subviews, and view is contained and controlled by a view controller. So at least in the in UIKit. So everything in this slide deck is now about UIKit. Yeah, so if you want to create some custom view to display some specific to your app data, you would subclass UI view. Basically, it just defines a rectangle on the screen and handles drawing and all the touch events like swipes, drags, taps, whatever. Every UI view can act as a parent for other views, so coordinating the placement and sizing of this views. And yeah, a view has just one super view, so parent view which contains it, and every view can have 0 or more subviews. Yeah, on iOS there are a lot of different standard views which you don't need to implement yourself, but just use them out of the box. Labels, switches, buttons, date pickers, and different controls. Pretty much all everything what you see, for example, on this screen is all default behavior. Yeah. Another example of view which often used in iOS apps is UI navigation bar. you always see it on the top of the screen. First, it helps the user to see what exactly is the purpose of this specific screen, which is opened right now. Then it lets the user navigate back using this back button. Also, you can show the name of the previous screen, so it's clear for the user where will they end up if they go back. There can be multiple actions on the right side, like editing, finishing editing, or whatever. Yeah, depending on the iOS versions, they can look a bit different. And in general, iOS handles a lot of stuff automatically. So when you rotate the device and stuff like that, it will be adjusted accordingly. And usually it's used with the UI navigation controller. We are going to talk about view controllers a bit later in this slide deck, but just so you understand, UI navigation controller is like a container for other view controllers, so that there can be multiple view controllers. And when you open the next screen, you can also go back to the previous view controller. And navigation controller can also have navigation bar, so the one which we discussed here, and toolbar, which we are going to talk on the next slide. And it also can have delegate, which will let you to react on some user actions. Yeah, then there is UI toolbar. This one is displayed on the bottom, can appear on the top for iPads. And yeah, it's used to add some actions for the user. Yeah, additional actions. UI tab bar is kind of similar. It's also displayed on the bottom, but the purpose is different. Normally, when you press on the buttons on the UI tab bar, you're supposed to navigate between different screens. So usually you should follow these kind of guidelines, because that's something what users got used to. And it's better to just always do what user would expect it, how user would expect it, just to not make it confusing for them. Yeah, it's really widely used on iOS applications, and the tabs can also show the batch numbers. So for example, if you here would have conversations or chats or channels or whatever, you could show the number of unread messages. Then UI text view and UI text field. They're like, the functionality is rather similar, but the purpose is a bit different. So text field is normally just one line input field, where you can also customize the input type. So depending on this type, the keyboard which the user sees will change. So for example, if you say that the input type for this field is phone number, then when a user presses on this text field, the keyboard with numbers would pop up. And UI text view is the also input field, but just for the plain text, and it can be rather long, and you would be able to scroll it if it gets too long. And here, regardless of the type of the field, when you press on it, so when the user presses on it, so when it's focused, the keyboard automatically appears, and you don't need to handle that, it happens automatically. UI search bar, it's also a standard view on from iOS, so from UIKit. There are a few functions which come out of the box. This is the placeholder text, like this one, bookmark, clear button, prompt. yeah, so you don't really need to customize or create anything yourself. It's already there. The only thing which you need to do is to implement the delegate again. A search bar doesn't actually search for anything. It just shows that, so shows the input fields, shows some buttons and stuff like that, but it doesn't search anything. And you need to create a class, or yeah, you need to conform to UI search bar delegate and pass this delegate to the search bar to implement the actions when user taps, enters text or clicks buttons. Another really common view is UI scroll view. It doesn't have any appearance, but it is just a container to other views which theoretically can be too long or too wide to show on one screen, so that if it is bigger, then a user would be able to just scroll to see the content on the bottom. It can be either vertical or horizontal. It also will show the scrolling indicators depending on the orientation of the scroll view. Supports zooming, so theoretically, if you want, you could implement some Google spreadsheet app and would use either UI scroll view or some of the subclass of UI scroll view to implement the tables. Can be used for pages. And yeah, can be a bit tricky to get right in the setup, but we're going to talk about that on the auto layout section of this slide deck, so a bit later. UI table view is actually a subclass of UI scroll view. So if you have too many cells to display on one screen, it will be scrollable automatically. These rows can also be divided into sections, and it also provides additional controls to add or remove rows. So for example, if you wanted to work this way, it would be possible to swipe one of the rows on the side and it would show some actions like remove the contact or whatever. It's also possible to implement it this way, so user can pick multiple rows. And you can also navigate to different screens when you press on the rows. But again, all of that works with the delegate. Actually, I think I could show you the demo for that. Okay, a bit later. Then UI stack view. Really convenient container for the views when you just want to display them one to another, so either horizontally or vertically without a complicated setup. Yeah, we are going to talk more about that when we will talk about auto layout, but what you need to remember is that UI stack view has orientation, axis, and it has alignment and distribution. So alignment is the way the views are displayed perpendicularly to the orientation, to the axis, and distribution is alongside to it. And yeah, also stack view can have spacing between the views. Yeah, there are map views from the MapKit framework. So you don't really need to use any third-party library. There are a lot of frameworks for basically any need from Apple. Then there is web view. If you want to display some web page in your app, it is not super common to display a web view in the app, but it is used to show some data, for example, like some privacy policy or terms of usage or something like that, what can theoretically change sometimes, and it's just easier to put the URL in the app so that when you update it on your website, it's also immediately updated in the app. So that's, I would say, common usage of a web view on iOS app. But yeah, theoretically, there are apps which just display all the screens as web views. That's also the way a lot of cross-platform solutions work. But yeah, the performance is usually not the best. Yeah, UI alert controller is used to display a dialog like that. So you basically just let user know that something happened, or to ask a permission to do something, or to confirm something. So for example, when a user is trying to remove something from the list or whatever, you may ask for a confirmation and then make one of the button red. So this type of button would be called destructive, so that to let the user know that this button actually changes something and it won't be possible to revert it. So now let's talk about the tabs which are used in the graphics on iOS. So the names of the classes, the first two letters stand for Core Graphics framework, and all these types are really commonly used in UIKit as well. So if any value is related to the views or to the graphics, you would use CG float type. It's used to represent the coordinates and yeah, all these properties which UI view can have. And it can be converted from or to double or float if it's a 32-bit system. So yeah, the name can be a bit confusing, but depending on the system, it's either double or float. Yeah, then CG point. It's a data type that represents a point in the coordinate system, and it has two CG float with X and Y coordinates. Then another one you need to know, it's CG size. It's a data type that defines width and height of some view. Another one is CG rect to represent the rectangle in the coordinate system, and it has width, height, which is yeah, CG rect, and an origin point, CG point. And there are a lot of properties which you may find convenient to use if necessary. But yeah, it's always useful to just look up the documentation, because you can never know all the properties which some class has, and you can probably never remember all of them. And the way the coordinate system works on iOS is actually kind of same as on Android. The origin is on the top left corner. It's 0, 0, and then it increases to the right and to the bottom. The unit which you use on iOS is point, and we are going to talk about why on the next slides. Pixel is the smallest unit a device draws, so it's the smallest unit which can change the color. Points are used as a unit in the coordinate system in order for the iOS to handle different screen sizes, and points allow views to be scaled independently of resolution. So back then, when all the iPhones, so pre-Retina devices, they all had kind of same screen size, and there was no need to really adapt. You could just build your app for one screen size and everything would work perfectly fine. But then when the newer iPhones started appearing, they got higher resolution, so that Retina devices all have just 1 point equals to 1 pixel scale. And newer iPhones, Retina iPhones, they have higher resolution, and depending on the resolution, 1 point can be represented as 4 pixels or even 9 pixels. And here is why we need to use points and not pixels, because as you see on the older devices, if you use pixels to define the size of your view, you won't be able to design just once for all the screens, because you will need to adapt for every screen, because if you define something as half of the screen on the higher resolution device, it will take just the whole screen on the smaller devices. That's why actually the same problem exists on Android. So they have the same problem because there are so many devices with different screen sizes. And actually the solution is the same. They use points as well, so density independent points, which depending on the resolution can have multiple pixels in them, and so that when you use points to set the size of your view, it will be displayed relatively similar on different devices, regardless of the resolution. And there is a link here if you want to read more about that. But yeah, the main point is that you should always use points so that your UI would look adequate on all the devices. You need to be aware of kind of two important properties of the view. First one is bounds. So it's relative to view's own coordinate system. So that would be bounds of this view. And the frame, it's relative to the super view of this view. And yeah, it takes all the place which takes all the rectangle where this view is displayed. So you need to remember that bounds and frame are not always equal. So you shouldn't assume that. And now we're going to talk about interface builder. But I guess we could take a 10 minutes break, if you don't mind. And then at 9:50, we would continue with the interface builder.
All right.
See you. So hello again, and now we can continue with the interface builder. Interface builder is a graphical tool to lay out UI on iOS, and it allows you to do pretty much anything related to the constructing the UI. You can define all the attributes for each element. You can set connections between elements or and wire them to the code. The information after you build your UI, information is stored either in storyboard or NIP or XIB files. They're kind of same. So all these files are essentially XML files, but storyboard is a kind of bigger thing. It can contain multiple screens, multiple view controllers, and you can see all the connections and navigation between view controllers. XIB files mostly used for smaller views, especially cells for the UI table view. Both NIP and XIB files do the same thing, but NIP file is pretty much a bundle, and you cannot really read this code, so it's kind of minified. It takes less space than XIB file, but you cannot really read it as code. But XIB file is just a proper flat file with XML code in it. But to the opposite, as it works on Android, on iOS, you normally don't work with the XML code directly because it is not as nicely readable as on Android, and to use just interface builder view. And yeah, auto layout is the most common layout manager to use. So here's how the interface builder looks like. And I guess we could just switch to it so I can show you everything. Yeah, that's how it looks. This is just a new project, and depending on what template you pick when creating a new project, Xcode can generate all of that for you. So let's just close it for now. Here is the interface builder, and here you can see just one view controller, which was automatically generated for this project. You can also see, just a second. Didn't use the interface builder for quite some time. Yeah, here it is. So you can also see the XML code where all the connections and all the views are defined. But as I said, normally you don't really look into it and don't really work with it. Yeah. This is the UI. So this is view for your view controller, and the code would be here. For now, it's pretty much empty. If you want to see both of them at the same time, you can split the view. Yeah, like this. Yeah, and then when you want to add a view to your screen, you can press Add button. Okay, something is, just a second. Just a second. I'm not sure why it doesn't show the collection of the views which we can add. Just a second. Works here. Just a second. Okay. Yeah, it's just a screen sharing issue. It's displaying on another monitor. Here it is. Okay, so here is the collection of the standard views which are available to you to add to your screen. It could be a label to just represent a read-only text, so it's not a text field which can be edited by the user. It's just a static text. Could be a button. There are a lot of controls, sliders, switches. Yeah, activity indicator view, really important to use it when you perform some requests to the server or doing some seconds or doing some long running operation to let the user know that the app is not stuck and there is something going on in the background. Yes, same for progress view. If you can estimate the approximate progress of your operation. Tables view, we already talked about them, and I'm going to show the separate demo for that. You can also design the cell for the table view, which will be showed as a list. Image view, different collection view. So table view is normally displayed just as a stack of elements, and collection view can be used to display different grids, stuff like that. There are also all the views which are specific to different Apple frameworks, like MetalKit, GelKit for low-level graphics, SceneKit, ARKit, Vue, different controls for the navigation. Also, in here you can pick different view controllers. So, for example, navigation controller. Navigation controller. Yeah, it will create view controller which where you could add, for example, the navigation bar or toolbar, and it will be possible to navigate to a different view controller. But yeah, we will talk in detail about view controllers a bit later. So let's, for example, add a button. And here on the side, you can see all the properties of the button, which you can customize. So it can be not just the standard button, it can be some custom class, which you wrote yourself or using from the library. Yeah, you can define all the states, colors, all the properties you want in the in this window, in the interface builder. But yeah, normally you wouldn't use interface builder for a few reasons. First is the XML. As you see, the more views you add, the more it grows. And then when you create a pull request after you implemented some feature, whatever, with a huge storyboard, and it is really hard to review this code because, yeah, just from this code, it's hard to see what exactly changed and how these values affected something, whatever. Also, another downside of it is that when two people at the same time edited the same storyboard, but on the different branches, it would cause a conflict, and it will be really, really hard to resolve such a conflict because, again, it is not clear what value. It's not super obvious what value does what and which one to pick if there is a conflict. And yeah, we are going to have a separate lecture on Git. But otherwise, the storyboards are really convenient to just try out some stuff or to build a prototype. It is really convenient for that and fast. But often programmers prefer doing building the UI in code. So let's open the view controller class. And I will show you how you can interact with your views in the code. This. So after you edit all the views which you want, for example, we can add a few more. A label. Text view. And in order to interact with them from your view controller class, you need to kind of connect them there. Right now, this storyboard view controller is already connected to this class. I will show you where. Here it is. Here it references this view controller. So they're already connected, but the views which you're added are not yet. So what you're doing is you press Control button, and then you press on the view and you drag it to your class. You pick the outlet. So this connection from the storyboard to the code, it's called outlet. Let's name it label. Here is the type, this is correct. And you can pick the reference type, either strong or weak. I would recommend you to use always weak reference just to get used to it. Because, for example, if you use UI table view or some view which can have a delegate, and if you have a strong reference to the view and then you pass delegate to this view, which is also referenced strongly, you can potentially introduce the reference cycle. So let's just keep it weak. And here it is. So all the outlets which you add to the view controller will have the outlet annotation, and now you will be able to interact with them. So you can set the text, for example, here, or you can set the text from the UI. So both options are fine. So for example, if the value, so the text for your label is static and not going to change, it's fine to just set it from the storyboard, but otherwise it's also possible to do from the code. Also, you're probably going to do it from the code if you're going to localize this text. So if you want your app to be translated to multiple languages, then you would do it from the code. Yeah, then let's connect us the button. Connect. Yeah, so you can also introduce the button here. And if you want to somehow react when the button is pressed, it's not what I wanted. Again, control click and right in here. You can also have an action connection. Let's name it button click. You can pick different types of actions. For the buttons, if you want to just set the click listener, you normally use touch up inside. Yeah, here it is. And all the actions which come from the storyboard would be annotated with the action. And this function is going to be invoked if you press the button, if you press the button. So for example, we could say button pressed. Yeah. You can also connect the text view. Again, keeping it weak. And can reduce the text view. Let's see. And yeah, let's just try to run it. Shouldn't take too long to build. Here's the UI which we built, and if you press button, yeah, this function was invoked and changed the text of the label. Let's see in the presentation what's next. Yeah, as I mentioned, all the views have multiple attributes which you can change, like alignment, colors, different states when it's enabled or disabled, stuff like this. This is how the XML looks like, the way the storyboard files are saved. And I already showed you how you can connect your views to the code. So you can as well do the same here, control click and do it from here. Yeah, and in the interface builder, you can set the constraints for your views. So as you see, now the views are not really properly placed. And if you want them to be displayed the same on different devices, then you need to set some constraints to them. So for example, if you want, just as an example, let's run it on some different device. iPhone 8, for example. Just yeah, as you see, it's a bit different. So if you want, for example, to center this view, you can put some constraints for the buttons, make it horizontally and vertically so that it's centered. And so yeah. So we also need we put constraints for the button both horizontally and vertically, but only one constraint for the label. So it's centered horizontally, but vertically it's just right on the top. And if you want to make some constraints on the top, you can say that this spacing would be 8, just the standard one, or 16. And as you see, this constraint is highlighted. That's the one which we are going to add. And now it will have proper spacing. You can specify multiple constraints. You can also specify constraints between the views. So you can build more complicated UI, and then you can see all these constraints in this property. What else? Yeah, that's what we already did. And yeah, before we're going to building the UI in code, I would also ask you to try to do the same thing yourself in the interface builder. And yeah, if you have any questions, to ask them. You would have like 15 or 20 minutes to try it out yourself. Okay.
Okay.
Let me know if you have questions.
Sorry, I have a question.
Yeah, go ahead.
How can I open both my code and the storyboard?
I will show you now. So here you see this button. Yeah, add editor on right. So when you press it, it adds additional view, and when you press on it, you can pick when or what you want to open.
Okay.
Yeah.
I see. Yeah, thank you.
I have a question.
Mm-hmm.
I get an error every time I click on my switch. Can I show you my code shortly?
Yeah, share the screen.
So, can you see it?
Yeah.
I run it again, and then I'll show you where the problem is. So my button works, but every time I touch my switch, I get the.
Can you please show me your view controller code? Yeah. And do you have any action on your?
Yeah.
You have.
So before I set the if statement, it worked. I only called the background color green, and then it worked. But after I set my if statement, I got this error.
Can you just curious? Can you go back to this state where you had just color engine?
So
and it worked this way, right?
No.
Switch action and selector. Interesting. Can you go back again to the view controller?
Yes.
Let's see.
Maybe I set something false when I drag and drop it in. Is that possible? My switch.
Control. Yeah, and then action. Which action did you pick?
The slide, I guess.
I think it should be
the default. The
no,
that's yeah, exactly. Value changed.
Yeah, let's try to do the same. It works.
Okay.
What is the difference with your solution? It just looks like this selector is wrong. But if you just drag and drop this, it should work.
Okay.
Interesting. I don't see why it wouldn't work.
Is it possible because I create my project without the data core?
Core data is not necessary in this case.
Okay.
So the core data is kind of the framework to use the database. So for now, it's not necessary. Can you scroll a bit to the top in your view controller again?
Mm-hmm.
Yeah, actually the same thing.
Maybe I delete this and try it again.
Did you do it before?
What?
Did you do thing like that before? Did you remove something manually?
Yes. Oh.
That could be the reason. I will show you now. So here's your switch, and here are. Do you see my screen?
I don't see anything.
Sorry. I will show you how that. Yeah. So here, do you see it now?
Yeah.
Yeah. So here's your switch, and when you pick the last menu option here, you can see all the connections. And if you remove it just manually from the code, it can stay, and then when you press it, it can see it as a missing value. You see, it's kind of still there. So if you pull it again, although the action, a new action is there. Let's just let me change. And then if I run it now, so that's kind of the tricky part of working with the interface builder, that you either then need to do all these actions from the interface builder and not to do too many changes manually, because you can just break something.
Okay.
Yeah, you see the same thing happened. Yeah.
Yes.
But yeah, that's why I prefer to do everything from the code, because when you use some UI tool, you kind of don't see what happens under the hood, and it can potentially.
Okay, and how can you fix it? So if you changed it, can you fix it manually or?
Yeah. So you go here, and that was the old one, and you just remove it. Yeah. Now
okay, then I try this, then it should work. Thank you.
Yeah. So imagine if you created a variable which is not optional, and then the value for some reason is missing, and yeah.
Okay. Yeah. Okay. Thank you.
So do you guys need a bit more time to try it out? 10 more minutes? So now I want to show you a small example with the table view, UI table view, and how the setup can be different. And then after that, we would make a small break and then continue with the built-in UI in the code. So here is the storyboard. There are multiple view controllers, just to display different ways how table view can look like. Yeah. So as you see, there's just plain table view controller. I can just run it to show you. So plain table view with just text. And then it can be grouped into sections. Another way of grouping. Sections like, for example, in the contacts list. So you could put just the first letter of the names or something like that too. Different cell styles. So as you see, there are different UI views and custom cells. So now let's see how it is set up. As you see, all these view controllers, they're kind of the same, but all of them contain table view inside. But the only thing that changes is the style. So there can be different styles. There can be also selection types if you want your user to be able to pick something. And now let's go to the plain table view controller. So as you see, this table view is connected to the storyboard view. So that's how you can see it, the annotation, and it's connected. And when the view is being loaded, you need to set up the table view. So right now, don't focus too much on these methods. A bit later, we will look into the life cycle of the view controller. So there are a few lifecycle methods which are being invoked at some point of time, depending on what state your view controller has. So what you need to know, this method gets invoked when your view controller is loaded. So table view always needs two properties, kind of. It's delegate, as I already told you, and data source. So delegate is needed to delegate some actions. So here view controller conforms to UI table view delegate and UI table view data source. In the delegate, we're selecting the roles. Just a second. It's the plain one. Doesn't really do much. Yeah, so the UI table view delegate is responsible for the actions which can happen. So, for example, you can have multiple. All the methods of the UI table view delegate are named table view, and then depending on the label of the second parameter, you can understand what this method would be responsible for. So, for example, let's pick the removal one. Let's remove. Yeah, return something. See. It's not the correct one. It's entered into the multiple selection. Let me check just a second. I think it's editing, so can edit true, and then edit style, delete. And let's say, and let's change the type. But it's at this point the row won't be deleted because we don't do anything. But actually, we could delete row at. Index path. Yeah, the index path is optional, so we need to make sure that it's not here. It should be possible to swipe it from the right and from the left. Yeah, makes sense. Also need to remove the element from the data. Let's see if it will work out. Remove it. I think I'm missing some of the methods of the toolkit. So can edit. Seems not the correct one. Yeah, here it is. So now we can delete it. As you see, it's just couple of methods of the delegate, and you can already have this functionality. And there are quite a few of them, so you can implement multiple actions. You can also change the animation style when you delete a role. So let's see. So they would disappear differently. So let's go to the grouped table view controller. So the same thing. In the view.load, we set the data source in the delegate. Also, I forgot to mention you need to register the cell class which you are going to use for the table view. In this case, it is just UI table view cell, so the default one, but you can create custom ones. I think here it should be custom table view cell. Where is that? Here it is. So as you see, you can subclass UI table view cell and build some custom UI with some different functionality. You can do pretty much anything, and you can as well connect it to the storyboard. If you remember, I mentioned that the storyboard files are used for multiple screens, multiple view controllers, and XIP files can be used for cells. Oh, here it is. Yeah. So here's the XIP file for the cell. You can do exactly the same thing as in the storyboard file. You can drag and drop views. You can change their attributes. You can also view it the same way. And connect them. Control click and do something with them. So let's go back here. So we registered which type of cell this table view is supposed to use. And we can use we can change the title depending on the style of the table view. So I think this view controller is reused for 2 cases. Let's see. Insert groups, grouped, and let's do it differently. I will come back here. As you see, this view controller class is reused for 2 storyboards because the functionality is pretty much the same, just the style is a bit different. There are a few other methods which you need to implement for your data source. So now in this case, we use data source because this is what we need to provide to the table view. Delegate is responsible for the actions, and data source is responsible for providing all the data needed to display your table view. So in this case, we tell that there are 2 sections, and in each section we are going to display the whole array. So let's say if we do 5. There will be 5 sections. Really easy. Another sections view controller. No, that was group. Now it's sections. So you would use sections to display the, just a second, let's go there. So as you see, the sections are a different type of the cell. They are displayed on top of the group of the cells, and it also stays kind of sticky to the top when you scroll. So let's come here. As you see, you again need to return number of sections for your table view, and then you say what is amount of the rows in each section. So if it's the first section, we show modern languages, and if it's the second section, we show older languages. The default one would be failure, means that something went wrong. And then we need to provide the title for the header of the section. So that's where we specify these titles. And here we return, construct the cell for each row. So depending on the section, we pick the data from one or another array. Let's see what else we can customize for the header. Header. Yeah, you can change height of the header. You can change view. Estimated height. So as you see here, we use just kind of default thing. But theoretically, if you want, you can make something fancy for the headers. Here you can use different cell styles. Let's see how that works. As you see, if we use multiple cell styles, we need to register all of them. Just set different identifier so that we can reuse them later. Again, we're going to have two sections. And depending on the section, we tell how many rows we have there. So in the first one, it would be 4, right? Yeah, in the first one, it's 4, and the second one, 2. And then we provide title again for the header in the section, depending on the section index. And then depending on the section and the row, we provide different types of cells. So it's not really a common thing to happen that there are so many different types. So probably this won't happen, but just for the illustration that it's possible, that's a good example. So if it's the first section, so this one, and depending on the type of the row, which we defined here, we provide different cells. So in order to obtain the cell, to set some values to it, you need to use dequeue a reusable cell from the table view, and that's where you use the cell identifier. Yeah. Again, yeah, it's better to reuse cells and not to construct them all the time, because there is only a limited amount of cells which can be shown at the same time on the screen. So you don't need more than that. Yeah, as you see, we dequeue different types of cells, and then we just provide different values to the views. Same goes in the second section. And here are the custom cells for this table. And Yeah, as you see, it's not always necessary to build the xzip file for your cell. You can also just subclass it and do something differently. For example, provide different styles. Yeah, Value1, Value2 subtitle. You can have different separator style. So this is the separation, this grayish line. Selection style, that's how you would select it, and you can change this color. Accessory type, I think we should use it somewhere here. Yeah, exactly. In the second section, we have different accessory types. This is accessory type is some default action which Apple provides you with. Users kind of already got used to these actions. They know what approximately that should do, and you can just use it without explaining what this action would mean. So when you see just an error, you would assume that when you press on it, another screen would open. If you have both arrow and detail button, detail disclosure button, you would think that there should some maybe explanation pop up, but not probably a new screen. Yeah, start like this. And let's see the accessory types. Yeah, it could be disclosure indicator, detail disclosure button, check mark. Yeah, like this one. Detail button or info button. And custom table view controller. Yeah, like this. Yeah, I already showed you when we use not the default UI table yourself, but the one which you defined yourself in the zip file. This is how you register it. You use UINIC class, pass the name of your cell, the name of the zip or NIP file, bundle is main, and yeah, the identifier. And here is everything pretty much the same. A number of rows, could be also number of sections if you want. So we could do it. Table view, number. First we would need to set the style. Custom table view controller. We would go in here and change the style to grouped, so that we can make sections. And now table view. No. So sections, title for header. Second, let's look again here. It's not called table view, it's number of sections. Let's say 2. Yeah. And then you can specify title. Title for header and section, and let's just return. So as you see now, we have two sections in here with the custom title. Yeah, like this. As you see, when you use the methods from the delegates, it's really easy to customize your table view. And now I think we can take just like 10 minutes of break, and we'll continue with the working on the UI from the code. So see you at 11:20.
Okay.
Mm-hmm. Okay, so now I guess we can continue. Let's go back to the slides. Yeah, as I mentioned, you can also build the UI in the code. The storyboards are great when you just begin to learn the new concept, the new language. It's also great for the prototype, but otherwise the storyboards are not really convenient when you work in a big team, or when there are multiple teams working on the same project. So there's always a high probability that more than one team theoretically can edit the same file at the same time, and then it will be really a pain to resolve the merge conflict. And yeah, it's always more flexible to just do everything in the code. You can have more complicated setup, and it's easier easier to see what exactly you're doing without opening the storyboard and check every attribute there. So the code is always more obvious about what you're doing. What I also want to mention, when you will start working on your project, you can, of course, pick the approach which you like more. You can use storyboards, you can use UIKit in the code, or you can even use Swift UI. So whatever you like the most, just use it for the project. It will be fine either way. So yeah, there are methods which you can use to build the view hierarchy from the code. So when you want to add a view to another view, you can just use add subview method. When you want to remove the view from its parent, you can you can use remove from superview method. You can also access all the subviews of the view. It's an array. And you can access the superview of the view. It's an optional UI view property. And you can also prevent a subview's content to exceed the frame of the superview. So theoretically, if you have a container view and there is a view inside it, depending on how you locate it, depending on what constraints you have, theoretically it can go outside of the view. It is possible in iOS. And if you want to avoid that, you can use clip to bounds property and set it to true. By default, it's false. And yeah, always check the documentation if you're not sure about the functionality of some class. Yeah, Apple has some documentation for each class of each framework, pretty much. You can see some explanation on top. Then there is the documentation for the methods which are in there, and you can see what you can do with the class. As I mentioned, there can be just one super view to each view. It's an optional UI view property. And you can access the subviews from it as well. Add subview. And let's go further. Yeah, so when you're doing something small, the difference is not that significant. So if you use the interface builder, you would have just the outlet for your UI view. And if you build the code from the if you build the UI from the code, then you would also have similar variable, and yeah, you can set the title from the code. So set title, and you can also change the title. If you set the title for the button, you can set different title for different states. So normal state, it's the one when the button is enabled but is not pressed. Button can also be disabled, can be pressed. Yeah, there are multiple states. And that's how you add it to the view. It's really easy. But yeah, as I said, when the screen grows, often it's more beneficial to do it in the code because you can exactly see what kind of setup is there without looking through all the attributes in the interface builder. And yeah, let's try to build a screen in the code. We pick app. Let's name it demo. And we don't want to use storyboard. Okay, we can just use storyboard. Okay, then we'll just use the same setup. And let's just create a new view controller. So when you, I will just go back real quick. So when you create a new file in Xcode, you can pick one of the many templates, depending on what you're going to do. For now, it's just Swift. Let's name it table view controller. When you create a new file in Xcode, you can also pick the targets. I'm not sure if you already talked about targets with Ralph, but depending on where you want to add your file, for example, if you create a new test class, there would be also additional target for the unit tests, for example, and you would add it there instead. Because you don't want all your files to you don't want to compile all your files for each target, because some target may not want to use all the files. Okay. Let's import UIKit instead. And we create the table view controller. It should always extend some kind of UI view control. Yeah, if we want to pass any parameters, we can also have init block, but yeah, not really necessary. I want to have view did load. And here I will add a variable for my UI table view. Let's also make it because we are going to provide the delegate for the table view. And then what we do, we add the table view to the view of the view controller. So the view controller always holds reference to its view. So we are going to discuss view controllers more a bit later, but in general, each screen should have a separate view controller, and also depending on the complexity of the screen, you can have multiple view controllers on your screen. So same as you would add view to another view, you can also add child view controllers to view controller. Add subview, table view, table view. We want to set the delegate self. Then we need to conform to this interface. And let's let's run the event. Number. Scott. Let me check. Number of rows. Yes. It's not delegate, so it's data source. Yeah, of course. We also need to set the data source. Write table view data source. Here it is. And table view number of sections. Oh, not number of sections, number of rows. And let's copy the same array from here. Data count. Now we need to provide the cell. Register. Cell class. It would be UI table view cell. That's what we want to do. Same way. Yeah, since it's optional, let's unwrap it. Like these, and then we want to unwrap the cell which we will predict here. Table view. How is it? Secure this. Let's just do this. It's optional. No, actually, no, we don't need to do that because in this method we receive the table view, which is not optional, so we don't need to unwrap it. Measures are the same. Yeah, actually, true. Just a second, let me check the delegate property. Yeah, actually it's fine. The delegate property is weak and data source as well. So it's fine, we will have it. There is a strong reference. And now we're done to inject. Looks good. And then if we go to another view controller, it's just just need the action. But yeah, otherwise you could completely remove the existing storyboard view controller and just use the ones defined in the code. Table view controller. And we would say present view controller. So the one which we created, animated true, and we don't need any completion. Completion, it's a callback which would be invoked. So it's a closure which will be invoked when the this view controller which we created here and which we are presenting would be closed. If you want to get any callback from that, but otherwise we don't need it. And let's see. Let's go back to the table view controller. Yeah, we should also set the constraints because now it doesn't know how to display the table view. So we would say ns constraint, layout constraint, activate, and here we can pass an array of different constraints. So when you use auto layout, in order for it to be able to automatically place other views on the screen and to determine their size, you need to provide some constraints for it to know how to do that. So we want the table view displayed just to the whole screen. Constraint. Constraint. No. So the views have kind of anchors, and you can use these anchors in order to construct the constraints for views. So how that would work? Then you use. So first you pick the anchor which you from which you want to make the constraint. then you say constraint equal to, and you use the root view anchor. You want to do the same with the body. Yeah, if you want to have some spacing, you can also use spacing here as a constant. And now we don't want that. Instead of using right and left anchor, we have leading and trailing. It also helps to adapt really easily if you have a UI, if you want to support languages which are going not from the left to right, but from the right to left, and it makes your app easily adaptable to the situation like that. So for the in the normal situation, in the default situation for the languages which we use, the leading anchor is the left one, and trailing anchor is the right one, but can be otherwise. So this constraint method returns constraint, and then each of these constraints needs to be activated. So you use activate method and pass an array of constraints. It's also common to change the constraints depending on the either device type or device orientation, if it's portrait or landscape. But we'll also talk a bit about that later. Yeah, come here. Yeah, so here's one of the constraints. Trailing, pattern. Mm-hmm. Let's just comment this out just for now. It still don't like it, but there are no break constraints. Just a second, I'm missing something. I'm missing something. Maybe let's try to do it to activate the constraints a bit later. Oh, that should be fine actually. I also called the wrong method here. That is probably not that. Let's see. Interesting, it wasn't invoked. And the name should be because there is also UI table view controller from SSDK, but it's not that. Bear with me, fine. Interesting. But this method is not invoked. Let me check. I think. And now let's for now just specify some hard-coded. I don't know why it doesn't like the bottom anchor constraint. Let's see. You can also specify the head anchor equal to constraint equal to constant. Let's say 500 points. Let's disable the debugger. Seriously. For some reason it has oh my god, I forgot. Yeah, that's what I forgot. This size. So yeah, when you have any containers view which you construct from the code, you never want, or almost never want, the outer sizing. So let's put it back to the bottom anchor. Go to view bottom anchor and also on the Craven one. Yeah, here it is. Always forget about this thing. Yeah. And in the same way, you can also add any other view which you want. It can be button, label, whatever stack, UI stack view. So, for example, if you would like to have a UI stack view, you would use it rather similar. Let's comment out the table view for now. Still need to do the same thing here, as it's also a container. And here you can use, you can add views to your stack view, but first you need to specify the axis. Let's make it vertical. And arranged subviews. Arranged subview. Let's add label, UI label. Let's also add admin. Set title. Oh, that's default, I think. Yeah. As you see, there are multiple states which the button can have. So let's pick the normal one for now and add button here. And everything went wrong. Here is the label, here's the button. Tokyo. What we can do to see what's going on here. We can view the hierarchy. Yeah, as you see, we didn't specify any distribution or element, and the text, the label took the whole space, and button is on the bottom. So let's fix this. Distribution. We want to have equally, and elements, we want them to be centered. Yeah, here's the button, here's the label. As you see, they're centered horizontally. So I guess we are running out of time. So that would be it for today. But yeah, as you see, when you're building the UI from the code, you can always see immediately what you're doing without just checking. All the attributes of the views. But as I mentioned, for your project, you can pick any option. It would be fine either way. And yeah, I will see you on the next lecture. I guess it's going to be more than in a week. See you.
All right, see you.
Yeah, see you.
Bye.
Bye.
See you.
Bye.
Bye.
Bye.